Empathy. It's not about me. So what exactly is it about? What is empathy? One of the most famous figures in the study of empathy is Daniel Batson, social psychologist. And he's written that there are almost as many definitions of empathy as there are researchers of empathy. That's a problem. So I'll give you my definition. I can't argue that it's the correct definition per se. It's the one I prefer, but there are other prominent researchers in the field that do not prefer the definition the way I give it. But for me, the definition of empathy is taking someone else's perspective without being overwhelmed by it. Take someone else's perspective without being overwhelmed by it. We'll see what that means. So what's necessary for empathy? Well, there has to be a self, the person that's observing, the person that's going to do the empathizing. There has to be someone observed, the one with whom the self is going to empathize. And the brain is very good at taking both of these accounts and holding them in the mind at the same time. But that leads to some problems. How do I know what feelings, thoughts, emotions that I'm experiencing belong to me versus the ones that belong to the person I'm observing? They're both in my head. How can I discriminate them from one another? How can I recognize that these feelings I'm experiencing belong to the other person, not to me? That's what's necessary for empathy. And what we're going to see through this talk is the importance that this self-other discrimination concept has taken on, at least in my research and many others' research as well. So I'll be talking a little bit about neurons today. As a social neuroscientist, I measure neurons in the brain. What are neurons? Neurons are brain cells, simply put. And what I try to measure are mirror neurons. Neurons that fire both when you perform an action, but also when you watch someone else perform that action. If you look at this image here, we see the macaque monkey brain, which is where the species in which mirror neurons were first discovered. What the researchers found, Giacomo Rizzolatti and colleagues at the University of Parma in Italy, they found that not only do these neurons fire when the monkey reaches for an object, as we can see here, the ice cream cone that the monkey's reaching for, and to the left of that, we can see what is called the roster plot. That is the amount of activity the neuron is displaying at that moment. And that's what they expected to see because this is in the motor system. These are neurons that fire when the animal has a plan to do something. What they didn't expect was to see that those same neurons fired when they watched another animal perform those actions. Fires when the monkey performs an action himself, they fire when the monkey watches someone else perform that action. Now, one thing I want to point out before we progress here is that you can see just by the roster plots, by those graphs, that the neuron is firing more vigorously when the monkey is actually performing the action as opposed to when the monkey is actually watching the action. So right there we have a candidate for what I referred to a moment ago, self-other discrimination. Now, one interesting thing about these mirror neurons is, yes, they're in the motor system, but they're not just saying, I need to move my right hand to grab that ice cream cone. They're actually saying, instead, I want that ice cream cone. So in another study by Rizzolatti and colleagues, they recorded mirror neurons from monkeys while they watched another person perform an action. So a researcher used a pair of pliers to grab a piece of food to eat. These are typical pliers where you squeeze to make the pincers close. And we can see the mirror neuron firing off to the right. By the way, these data are not the actual data, just in a full disclosure, but the general essence is there. So when you squeeze to grab the food, that is when the person being observed squeezes the pliers to grab the food, the neuron fires vigorously. But what about when we give the person, the human, a reverse engineered pair of pliers? Now, to grab the food, to get the pincers to close, you actually have to release pressure from the pliers. Two completely opposite tactics, like we think of the motor system. Well, if I'm going to use a squeeze, I'm going to fire these neurons. If I'm going to open, I'll fire a different set of neurons. Completely different tactics, but the goal is identical. And we know that these neurons are coding not the tactics, but the intentions, because they fired the same. Those mirror neurons fired the same, whether the tactic was to squeeze or was to release. It's pretty fascinating. In your motor system, your desire to do one thing or another is instantiated. It's not the action itself, it's the desire or the intention to do it. Now, how do I measure mirror neurons? I do not measure mirror neurons in non-human species. I don't do that sort of work. I think there are many questions to be asked about doing non-human animal research. I focus on humans, and I do so by using electroencephalography, EEG. You've all heard of brain waves. Many of us use the term, oftentimes perhaps not knowing exactly what we mean by brain waves, but it looks like this. Here are various frequencies of brain waves in the EEG. And on the right is an actual subject that we ran recently. He was a little wacky. So how about this EEG signal? How can I use EEG to measure mirror neuron activity? Well, in that case, we're honing in on a brain wave we call Mu Suppression, as the Greek letter mu. And just to give a caveat briefly, we do not know for certain that this Mu Suppression signal is measuring mirror neurons specifically. We know for certain that it is picking up mirror neuron activity, but we don't know how much of what we're seeing is mirror neurons versus some other signal. So I'd like to make that point there as a cautious scientist, that we want to be careful. And so instead of talking about mirror neurons for most of the rest of this talk, I'm going to talk about Mu Suppression under the assumption that there is a strong correlation between Mu Suppression and mirror neurons. Now, what do we get when we measure mirror neuron activity to the self versus mirror neuron activity to the other? Well, we get effectively what you see in the monkey, which is one of the reasons we believe Mu Suppression is showing us mirror neuron activity. This Mu Suppression signal is stronger when the human performs the action himself, as opposed to when the human observes the action being performed. So it looks just like that self-other difference in mirror neurons. And you can see over here on the right, by the way, just a sketch of the head, and the electrodes we typically record from are right here over the center, right over where motor cortex lies. Now, let's look at one of the first studies we did in this line of research, where we said, well, let's look at the Mu Suppression you get when you watch someone else perform the action, and let's correlate it with your level of empathy. For each participant, we did the EEG recordings, and separately we had them fill out a well-established, well-validated empathy questionnaire. And of course, we expected to find a positive relationship. We expected more Mu Suppression, more empathy. We found just the opposite. It all so often happens in science. And interestingly, when you get the opposite of what you expect, it can also be the most stimulating, the most exciting, maybe the most important, because it's the results you don't expect that cause you to really start thinking and inspire you to figure out, well, how could it be just the opposite of what I thought? And that's certainly where I was at. Empathy. How on earth could more mirror neuron activity be related to less empathy? So, as I thought about it, I thought about the participants that we ran. As with most psychological sciences departments and universities, we're running typical, healthy undergraduate students. Not the most diverse population, of course. And so you see here that negatively sloped line, that negative correlation between Mu Suppression and empathy. But this conveys the idea that we're only looking at people that are typical highs, typical lows, and in between. What we didn't have in our populations were atypical individuals. It's argued that some folks with autism have difficulty with empathy. There's clearly issues about empathy with psychopathy and various mental disorders that are related to low empathy and are also apparently related to virtually no Mu Suppression. So I want to say, in the case of autism, there is controversy. There are studies that have found one set of findings, studies that find the opposite. Some studies have found that people with autism have virtually no mu suppression when they observe others. Other studies have found, hey, it looks like their mu suppression is perfectly fine. So this is a controversial topic, and it's important that we be careful with this because we're talking about people with lives that are affected by how we scientists characterize their autism. I don't want to run around saying people with autism simply lack empathy because it's much more complicated than that. However, they seem to lack some mu suppression and do have some difficulties with empathy, at least certain subsets of the population of autism. And we know from our study that people that are high in mu suppression also are lower in empathy or perspective-taking abilities. So we think that maybe this negative correlation we got by looking only at typical college students may just be the right half of a curvilinear or a nonlinear correlation, such that there's a sweet spot in the middle. You don't want to have zero mirror neuron activity or zero mu suppression because that seems to be associated with lower perspective taking or empathy skills. And you don't want to have maximal amounts of mu suppression because that seems to be associated with poor empathy. Instead, you want to be right there in the middle. You want to be at that spot that is created by self-other discrimination. The one that says, yes, I'm observing this person distressed. Yes, I am distressed. But the distress belongs to that individual. That allows me to not become overwhelmed. I think the folks over here on the far right of the plot, the typical college students who were lower in perspective-taking abilities, I think they had too much mu suppression. They experienced too much of what the other person's feeling, such that they basically go through fight or flight response. They can't really keep their attention focused on the other individual because they're worried about the distress they're feeling. The person in the middle gets to feel some of what the other person's feeling, but kind of keep a lid on it and kind of keep it compartmentalized so that the mind doesn't get confused about what emotions belong to who. So let's look at self-other discrimination if we can. I mentioned here at the bottom we see the image on the right for the monkey's mirror neuron activity when he performed the action himself, and we see the plot on the left where the monkey was observing the action. We mentioned that self-other difference. We see that self-other difference in the mu suppression as well. So maybe what we could do is take that mu suppression to watching the other person that is surprisingly negatively correlated with empathy. Maybe we can subtract that activity out of the mu suppression the person gets when they perform the action themselves. So what we'll have is a different score, a score of self-other discrimination abilities. How well is the brain separating your own emotions from the other person's emotions? And the larger this bar gets, the more self-other discrimination one is capable of processing. So how does that correlate to empathy? Suddenly, that negative correlation flips to a positive correlation. Suddenly, the more self-other discrimination you get, the more empathy you're able to display. We've got a measure that can predict how well a person can empathize based on how large of a difference their brain makes between whether they're experiencing the emotion or the other person's experiencing the emotion. So we need self-other discrimination. As I already said, it's necessary for empathy, and I've met very few people that say empathy is not a good thing. There is the school of thought out there that says that there are downsides to empathy. That again has a lot to do with whether you buy what I'm saying about self-other discrimination. Regardless, we can't just have other people's feelings, thoughts, and intentions flooding into our heads without some way to keep them separated. Otherwise, we're liable to act on other people's emotions and intentions. If you start crying and I have no self-other discrimination, then I'm going to start crying. And I am not going to be capable of saying this crying belongs to you. I'd say it belongs to me. I sometimes wonder if sardines have mirror neurons. I've not been able to find a sardine physiologist. There's got to be one out there somewhere. But so I have no idea whether sardines have mirror neurons. But I like them as an example because they are one of these shoals of fish that move almost as a unit. One turns left and all the others turn left as well. And there's some really nice, very simplistic mathematical calculations for this. They just keep a certain distance and nice algorithm. That may or may not be consistent with the theory I have about mirror neurons. If it's true that these sardines have mirror neurons, then when Sammy Sardine turns left, Susie Sardine turns left also, because she observed Sammy Sardine's intention. It had turned to an intention to turn left in her head. She has no self-other discrimination and therefore is going to act on the intentions expressed by Sammy. Let me say, I'm very much into animal welfare and ethics, and I have no idea whether sardines have a sense of self, let alone self-other discrimination. I'm not trying to make a claim on that, but rather illustrate a point. If I can't discriminate my intentions from yours, then I'm liable to act on your intentions. And maybe that's how this schooling behavior comes about in the sardines. But we have self-other discrimination, and we need it, right? We have the ability to not just behave like everyone around us. We do, I hear on Facebook a lot these days, people throwing around the word sheeple, right? As if people are sheep following one another around. So sure, there's a lot of that, and in fact, there's a lot of benefit to us being able to imitate and act like one another. That's another talk, though. There's also a lot of benefit for not acting on other people's beliefs, intentions, and goals. As you see, the case of this gentleman here, who apparently was a genuine Nazi dissenter, and I just love his face because he's got this look like, you kidding me? You buy this? Right? Okay. So all this research has brought me to what I call the empathy to compassion model. Let me say up front, this is not a model of the only way to get to compassion, because compassion can be achieved in instances without empathy. But there certainly are times, as we're all very familiar with, where empathy leads to compassion. It's that process that I'm trying to model here. And I do that by focusing on self-other discrimination. If we look at the y-axis on the left, we see self at the bottom, other at the top. And so I consider that a continuum of self-processing that slowly morphs into other processing as you go up the bar. You could think of it as the focus of attention. Am I attending to myself, or am I attending to the other person, or am I somewhere in the middle of that? Okay? So let's follow that focus of attention. If you fail at self-other discrimination, then you're going to follow this first kind of ejection route, I call it. You're going to experience personal distress. That is, you're experiencing the distress of the other individual, but you're not recognizing that that stress belongs to the other individual, and you're responding to it much as though it were your own. And this is going to kick off your fight or flight response, that autonomic nervous system response that is designed to save us from danger. And of course, it's to save me, not you. My fight or flight is not about saving you. My fight or flight is about saving me. So if I'm experiencing that fight or flight, my attention is necessarily down here toward the bottom of that self-other spectrum. I am necessarily focused on myself. And according to my definition of empathy, if I'm focused on myself, I can't be experiencing empathy. All right, now that's the route, as I say, the ejection, the escape route, if you will. In fact, that's what you usually want to do when you experience personal distress. You tend to want to escape the situation rather than stay and attend to the other person. But let's say in the sympathy to compassion route, you go through that initial simulation process, which is mirror neuron activity. At that first instant in time, your mirror neurons are responding to the other person's actions. But you haven't had time for self-other discrimination yet. All you've done at this early point in time is simulate the other person's experience. Now, if self-other discrimination can kick in, you can now shift that attention toward the other individual. You could say, these are not my distressful emotions. I'd like to see what's going on with this person. So if simulation was asking, how do I feel? Empathy is asking, how does the other person feel? But we can follow this further to the stage of sympathy, which I define as, how does the way this person feels make me feel? Now you see that this focus of attention is oscillating back and forth between self and other representations. Yes, it's spending more time in self. Why? Because the sympathetic question, how does the way this person feels make me feel, it's ultimately about me. The end of that question is, how do you feel? I still need to know how you're feeling. I've got that from empathy, and I'm still reflecting on how you feel, but it's mostly about how I feel about what you feel. And once I've gone through that sympathetic stage, I can now shift that oscillation from favoring the self to favoring the other. Compassion. What can I do to help? Now, notice compassion is not completely other-focused. That's what makes compassion different than empathy. Empathy is completely focused on the other person. Compassion is considering the self. Compassion is what can I do to help? It's mostly driven by the concern for the other individual, but it does require some self-reflection. Not as much as sympathy, because sympathy is biased toward, how do I feel about this? Compassion is biased toward, what can I do? How does that other person feel, and what can I do for them? And that's the empathy to compassion model, again, based on self-other discrimination. And empathy is clearly something that we all need to get better at performing. We can practice it. Indeed, Steven Pinker from Harvard Social Psychology Department has argued that the single greatest invention for us in terms of our improvement in empathy has been the printing press. The printing press. The printing press brought about the advent of novels. Novels weren't possible before because novels are mass distributed. Okay? And plus, not many people read, but as people started to read, because there's lots of books suddenly around them, they're reading novels. They're reading fictitious stories usually about individuals. And the better the author, the better the reader is able to empathize. And so suddenly, in the 1400s, mass amounts of individuals started reading and practicing empathy. They didn't necessarily know they were practicing empathy, but they were, and so they necessarily got better at it. And since then, we've just had media explosions, right? All kinds of information, all kinds of sources from which we can get stories and information about other individuals. So despite what most people believe, that we're becoming less empathetic, that we're becoming more violent as a society, it's actually quite the opposite. We are clearly on a multi-century decline in violent crime, in the likelihood that one is going to experience violent crime. So we're getting less violent, and at the same time, we're getting more empathic. So let's go out there and keep learning. Thank you.